Hi, my name is Dennis Bertram. As you may know, I'm interested in distributed technologies, and one of the things that I've been really thinking about a lot is how we can take the state of our applications out of the providers of our applications and put them on what I like to call the global state. The purpose of that is we can enhance the security and privacy of users when we separate the source of an application from the state of the application. To demonstrate that, I built a combination of technologies that demonstrates a part of this idea. Basically, what we're incorporating here in this project, which is called Vendor, VNDR, is Ethereum, the IPFS network, and the OrbitDB mutable database structure built on top of IPFS. IPFS, as you may know, is the interplanetary file system, and it's a hash addressable global namestate file system which persists across thousands of computers around the world simultaneously. So what's special here, what you're seeing here, this is a created with React app. This is a simplified version. But here, what's happening is the state is coming from the Ethereum network and the IPFS network. So here in this case, the idea of Vendor is you can create a store as an Ethereum address holder. You can create a store and then create products on the store, which you can then sell. Because the store is persisted in the Ethereum network and the IPFS network, what this means is that even though I'm providing you the app, I am not the owner of your store. So while I may provide you a convenient gateway to get your store, you can actually get your store from another portal, from another avenue, right? You don't have to get it strictly through me. What this means is that I can't shut your store down if I disagree with what you may be selling. This doesn't include any technology to obfuscate or hide who you are. So if you were selling something illegal, for example, you could still be found, but it prevents moral or political concerns censoring what you may be selling. Of course, this technology can be used to voice political opinions, ideas, creative works, other things. It's not only for selling things. So in this case, what we'll do is load store. As you see, we're connected to the blockchain. And this is our sort of amount here of how much money you have in your account, your address. The IPFS-REDUX sort of gives you an indication that the browser has instantiated its own version of the interplanetary file system node. This means that the browser itself is holding this. This isn't coming from the server on the back end. So in this case, because there is no store, I'm going to connect to an Ethereum contract written in Solidity that is already deployed on my test Ethereum network. So go to create store, Dennison's great test store. We go create. What happens now is we bring up the Web3 provider that's currently incorporated, which is MetaMask. I pay a token amount of money, actually $7, that's not so cheap. But we do confirm. And now while our contract is loading, which you can see here, we're going to wait for a confirmation, which should come any moment. Hopefully it comes on this screen. Let me check my store, so it hasn't come yet. 1, 2, 3. What we're doing is we're waiting for, there we go, confirm transaction. So if we load, now I have a store that is registered in the Ethereum network. From that process, reload, we go in, we reinstantiate our connection to the Ethereum network, reinstantiate the IPFS network, reinstantiate our node or OrbitDB instance. You can see that the amount of money I have has been decreased, and now I actually can create products. This isn't a full implementation, so the only thing that I can do actually at this moment is create products. But so if I go to create product, I'll make Dennison's great product, delicious, quantity 1, price 1,000, because I'm worth it. So we go ahead, we go create. Once again, this is a process that is going to interact with the Ethereum network. What's happening in the background right now is actually very interesting, and I'll show you, if I can, through the state. So there's a lot going on over here on the state while we're waiting for the transaction to confirm. But actually, I'm taking this object that I've created, this new product, and I'm hashing it when I store it in the IPFS network. Then the hash that comes back from that, which is its addressable file point, is being put into the Ethereum network. So now I don't need to store my entire product information, because you can imagine that there could be a lot of data, pictures, video. Rather, all of that is being put into the IPFS network while I keep the head of this, what it's going to show as a linked list in my Ethereum smart contract. Right? So just to give you an example, let's make one more thing. Denison's other great product. Delicious times 1,000. Right? So we'll create another one. Confirm. Now we're going to wait for that transaction to confirm on my test Ethereum network. So while we're waiting for that, I can show you some other things over here. We have my instantiation of my market, which is the contract interface adapter to the Ethereum network. This is the state that's being put into IPFS. I saw the transaction confirmed. So if I load my store again, actually I don't have to do that. It's created over here. This part I haven't finished because it's sort of been a big project. It's only been 4 days. But to give you an idea, I'm going to give you a previous reference. If you follow this, take this link, what it does is it actually takes you to the IPFS project's homepage, right? That's a portal that they offer to IPFS. And that's actually unique, right? That's not on my server or my computer. That's somewhere else entirely. But I went there using the hash that I just saved in the Ethereum network. And Delicious times 1,000, Denison's other great product, right? So this JSON object was being stored there, which represents this product, isn't on my machine. This was created and entered into the IPFS network on my browser, in my browser instance, but it's instantly available to be replicated globally from any other client that may request it. From that, if you take this previous hash here, which represents, this is sort of the idea of a linked list being built up in immutable state. If I just replace that here, you'll see that that's Denison's first product, right? So what happens is when you're building a store, you're actually creating this immutable linked list of products that you've added to your store. For the goals for the future to expand upon this, the idea is that when you complete it, you've completed your store, you've added your products, is that you will have the ability to actually eject the entire project. What that means is it wraps up all the code of that would normally come out of Webpack, including your HTML, your CSS, and it puts all of this into the IPFS network and returns to you this 32-character hash. With that hash, you can now reconstitute your store through any IPFS portal anywhere in the world. That means you put it in, you get all the application's data that you need to run your application. It goes out and searches and then sucks in all the state required to reestablish the state of your application so that it's live. But then anyone else you could simply give someone else this address and they can open their browser, create an IPS node in their browser, and then reconstitute your entire store on their end, from which they can go ahead and purchase products by buying them through the smart contract on the Ethereum network. So that was a lot, big mouthful, but that's my Stackathon.